This presentation is to introduce broadband service providers to the netElastic virtual routing solutions, including the virtual broadband network gateway and the virtual CGNAT router. First, let's look at the current landscape in the broadband industry. The coronavirus pandemic has driven a huge rise in residential traffic and has shown a bright light on the inequalities baked into the delivery of broadband globally. This has driven broadband service providers, or BSPs, to connect more customers, pull more fiber, and try to deliver more upstream bandwidth. Weak players have consolidated into stronger competitors, and these have attracted large investments. Boutique WISPs have become real businesses, and municipalities and electric utilities in underserved areas are deploying their own internet service. To keep up with all this growth, BSPs are upgrading their networks to keep ahead of the demand. The result is that the router market is poised for rapid growth. Yet service providers need to keep expansion costs under control. Enter virtualization. Virtual routing is a relatively new concept that has been driven by advances in semiconductor technologies. Optimizations in the x86 architecture are outpacing those in merchant and OEM silicon, driving costs out of use cases traditionally served by the big router vendors. While traditional routers have a place in the core, for aggregation, access services, and subscriber enforcement, they can't deliver the TCO that a virtualized solution from netElastic can. The netElastic vBNG runs on x86 servers, allowing service providers to deploy routing capacity on inexpensive and upgradable hardware platforms. By leveraging software virtualization, routing capacity can be deployed and scaled effortlessly. And enhanced functionalities such as CGNAT or BNG subscriber management can be deployed at any time in the future by the application of a license with a simple click of a mouse, all on a single 1RU server. By leveraging advanced data plane technologies, a netElastic router can deliver up to 360 gigabits on a single 1RU server on 10, 25, and 40 gig ports. And by scaling out servers, a BSP can deliver terabit performance upfront or over time. The control and data planes scale independently, allowing you to assign power to either as you require. Scale up the routing performance as needed so you can make minimal upfront investments, yet still preserve the ability to grow your routing performance. Add features and functionality when you need to, without having to rip and replace, like with proprietary routers. For example, you can start with a basic L3 router and then add CGNAT capability in a year and full BNG functionality down the road. Because it runs on mass market x86 servers, the cost to deploy a virtual router is about 30% of the cost of a proprietary one. netElastic licenses the vBNG perpetually, so there are no annual charges beyond support, or by a subscription model. And because of the powerful configuration and management tools provided and availability of spare parts, OpEx and downtime are significantly reduced. Now let's take a look at the netElastic vBNG. A vBNG, or Virtual Broadband Network Gateway, is an edge router with built-in subscriber management services. It's typically the subscriber-facing router in a service provider's network. It provides endpoint termination of Layer 2 tunnels. It provides authentication, authorization, and accounting services, so a user can log onto the network and work at agreed-upon speeds. And the BSP can monitor aggregate usage to keep up with SLAs. It provides QoS for congestion management. And lastly, it routes subscriber traffic to and from other networks. We support all the protocols and subscriber management tools service providers need. This includes dual stack IPv4 and IPv6, carrier network protocols like BGP, ISIS, OSPF, etc., and subscriber management enforcement functions, as well as 4 million CGNAT sessions. As we said before, a BNG typically sits behind the OLT or wireless access points at a network and turns the Layer 2 traffic into Layer 3, while providing subscriber management, congestion avoidance, and multi-WAN routing. It typically interacts with the BSP's billing system through a radius database or can store subscriber data locally. It also interfaces with the management network, including the BNG Manager GUI and other kinds of management tools, either in-band or out-of-band. The netElastic vBNG can be delivered as software to run on your favorite hardware, or netElastic makes several convenient appliances based on LAN or hardware, available for broadband service providers who just want a solution. Now we'll take a look at the netElastic Virtual CGN router. The netElastic vCGN router runs on white box servers or network appliances and allows service providers to conserve IPv4 address space by implementing a native IPv6 network alongside the IPv4. It provides up to 4 million sessions per instance with full NAT logging, either locally or to a syslog server for CALIA lawful intercept compliance. It provides a one-click upgrade to a full BNG when the circumstances demand, and it uses full same intuitive CLI and GUI found on the netElastic vBNG. It's a great alternative to the A10 Thunder or other line card-based CGNAT or large-scale NAT routers. Now let's take a look at some of the more popular use cases for the netElastic virtual router. The first and most popular use case for the vBNG is network refresh. Often this is due to the fact that service providers need to connect upstream at 10 gigs. But it might also be for reasons of support, or maybe a desire to reduce the space, power, and cooling costs. The ASR1K is a very popular router, and here we compare it to the netElastic vBNG 1202 on a well-provisioned server. This slide compares the vBNG 1202 to the ASR 1006X, a very popular router found in service provider environments today. We can see that the vBNG supports more subscribers, offers faster performance, the flexibility of virtualization, huge scalability, BNG and CGNAT functionality built in, lower power consumption, and a smaller form factor, and lower deployment and support costs. The first and most popular use case for vBNG is network refresh. This is typically driven by the need to connect upstream faster or support larger subscriber populations. But it might also be for reasons of support cost or maybe a desire to reduce space, power, and cooling. The ASR9K is a very popular router, and here we compare the 9901-120 with a single BNG license to the netElastic vBNG 1202 on a well-provisioned server. We can see that the vBNG supports more subscribers, offers comparable performance, the flexibility of virtualization, scalability beyond 120 gigs on the same chassis, lower power consumption and a smaller form factor, lower deployment and support costs, and an included web GUI for both configuration and management. Another popular reason to choose netElastic is because of scalability. Scale up over time by adding resources like memory, NIC cards, RAM, to increase subscriber count and routing throughput. Buy a big enough server to meet future needs, or choose to upgrade a CPU later, which is still far more economical than buying an ASIC line card. And scale out by adding additional servers locally or in a distributed fashion. The third popular use case is the distributed edge, sometimes called network segmentation or mobile edge compute or other terms. Traditionally, routers were deployed in the core, and Layer 2 network traffic flowed over the Metro Ethernet ring to the BNG. This model served the industry well for years. Disaggregation allowed the network servers to drive down costs and improve flexibility and scalability, but the chatty L2 traffic still transited the costly Metro Ethernet ring. But disaggregation also allows the BSP to migrate latency-sensitive functions closer to the user. This improves performance, lowers latency, enables a cloud edge, and provides local caching of content, creates a smaller fault domain, a smaller attack surface, which provide a more resilient network overall, and it keeps the chatty L2 traffic off the metro ring, keeping costs under control. This allows the service provider to make precision investments to improve their business economically. The fourth popular use case, or better said value proposition, is the way we handle network management. Firstly, we provide ConfD, a Cisco CLI, so your network engineers have a familiar way of configuring and managing the router. Second, we bolt into the popular management systems through a standard netconf interface. But what we're mostly proud of is our robust network GUI. The netElastic vBNG Manager gives you a view into all the BNGs and CGNAT routers on your network. You can drill down into the router, into the interface, and into the subscriber. You can put a subscriber in a watch list and visualize their traffic over time. You can run pings, radius pings, trace routes, packet captures, and more. You can even access the vBNG Manager APIs so you can develop web apps that call vBNG functions. You can also define roles so you can assign basic configuration tasks to junior engineers while reserving the more complex ones for CLI jockeys. A little bit about netElastic. netElastic is a Santa Clara, California-based software developer of software-defined networking technology, and we've been serving the broadband industry since 2015. We're a team of 60 or so networking and virtualization experts spread between Santa Clara and China. We're part of the Intel Network Builders program and have been on the Leaders Board for the past 2 years. And our secret sauce really is a deep set of data plane and user interface intellectual property. So in summary, the netElastic vBNG is performant, developed specifically to run the x86 architecture, and delivering line rate performance up to 360 gigabits per second. It offers flexible scalability, a true SDN architecture with separate control and data planes. Superior scalability aligns cost with revenue, and it supports very small to very large use cases from 2,000 subscribers up to 500,000. And it has a low TCO. It's an all-software solution, so it eliminates high upfront CapEx. It runs on x86 servers, any brand, and it offers a perpetual licensing model for both routing and subscribers. Thank you for spending your time with us today. We'd love to talk with you and your team about your routing strategy and learn how we might help you improve your service and your bottom line.